Hello and welcome to AI4. Our next session will be led by Charles Givre. He is the Vice President, Product Owner, Data Analytics, Cybersecurity, Technology, and Controls at JPMorgan Chase. Please join me in welcoming Charles to the virtual stage.
Thank you very much for the introduction. All right, so let's get into it. So the topic that I'm going to discuss today is data at rest and unlocking data in REST APIs. So what might just let me share my screen here. So just a bit about me. I'm a data scientist and product owner at JPMorgan Chase. I'm the project management committee chair for the Apache Drill project. I co-authored an O'Reilly book with Paul Rogers on Apache Drill. Prior to that, I was at Booz Allen for 7 years. And then before that, I worked at the CIA. My background's in computer science and music, and there's a list of places I've somewhat been affiliated with. In my spare time, I play trombone and I'm fixing up an old British car. So, okay, with that, let's kind of get into it. Just kind of a bit of background. One of the big pain points that I've observed over the years of doing analytics in large enterprises is that oftentimes enterprises will make an effort to make their data accessible by using a REST API in other words, they'll put their data such that it can be queried via the REST API. However, it does create some complications for analysts to actually be able to use that data. And so this talk is going to show you how you can really unlock the data that is contained within a REST API. So with that said, let's dive right in. So just kind of a bit of background about how they work and why they work, if you're not familiar with it. The basic premise is that a REST API enables you to access data with an HTTP call and so it allows this separation between the client and the server. So you can create a true data layer and then visualization layers or other layers. Now, the goal of this being that ultimately it makes data accessible, meaning that typically what happens is you might have some sort of reference data repository and you want a certain group of people to access this reference data, but you don't want to give them access to the entire database. So what you can do is you can create a REST API that has a query, and in that query, it just a user can just access a specific part of that, or perhaps execute a very specific query, and then they'll get results in a predefined manner. And so the idea being, again, that in theory, a REST API can make data more accessible. And what I've seen this done is with like reference data, I don't know, just all kinds of data like that. And the way this works, this architecture pattern should look pretty familiar to most people, I think. Is that the person who's wanting the data will make an HTTP request to some REST API, and we can essentially think of a REST API as a black box, and then the REST API will do whatever it does. It will query a database, or it will do whatever, and then it will return this data in a commonly or an easily consumable format, which would typically be JSON, XML, or CSV. Now, what are the problems with this approach? Well, the problems is that first off, there can be a lot of complications with this. The most obvious of which is that many times business analysts are not really familiar with the intricacies of making an HTTP request. And so if there's any kind of complication, such as authentication or any kind of security factors playing in there, or if there's just anything that makes it a little bit more complicated, it can very easily exceed a kind of a business user's technical ability to actually get at the data. And most often, what I've observed is that REST APIs typically require a user to use command line tools to actually access this data. And again, this is simple for something like this, but if you have a more complicated API that requires GET or post requests or authentication or dealing with a proxy server or anything like these, that makes it a lot harder. Now, there are tools out there that are very good tools that for querying REST APIs that have graphical user interfaces, but these tools tend to be more of development tools rather than what I would consider analytic tools, meaning that they're there really, they're not going to help you like analyze and visualize data. They're there to help a developer debug an API. The second problem with REST APIs and dealing with REST data is that while you might get lucky and you might get an API that returns a CSV, which can easily be put into a spreadsheet or a table, you more likely are going to get something that looks like this on the screen, which is JSON data. And this example here is heavily nested JSON data. And so this kinds of data does not necessarily translate well into directly going into a spreadsheet or something where you can do further analysis. So, well, having observed this for some time, I've kind of come to the conclusion that there absolutely has to be a better way of doing this, and hence the title of my talk, There Is. And so what I'm going to do is demonstrate how you can use some open source technology called Apache Drill to just query data in an API that as if it was a database table. And so this is based on some work that I've done, some contributions that I've made to Drill, but basically what this enables you to do is it enables you to directly query data that is contained in a REST API, and it completely abstracts any of the technical complications of querying this data. So how this works is, so if you're not familiar with Drill, Drill is an SQL engine for self-describing data sets. And basically what it can do is it can act as a data abstraction layer so that an analyst can enter in an SQL query, and Drill can interpret that SQL query, transmit it to an appropriate storage system or file system, read the results, map those results back to a table, and then return those results in an easily consumable format. And that's what you're seeing here in the diagram, is that an analyst would enter in a query, Drill would then send that query to the REST API. The REST API would do its thing, return the data back to Drill. Drill then would map that to columns and rows, and then the data comes back in a much more easily consumable format. Now, what you saw, this is what it looks like from the technical perspective, but what it looks like for the user is that they really can just enter in an SQL query into either a graphical user interface or a command line, and the Drill would then execute the query, do all that stuff, and just get their data back. They don't need to know about all that plumbing that's happening behind the scenes that all those complications that can be completely invisible to the end user. Now, a very big advantage in my view of Drill is that it uses standard ANSI SQL. And so what this does is this has the effect of opening up all this REST data to business users or people who are comfortable with SQL already. So really, if you know SQL, there's really nothing new that you have to learn. And as I mentioned earlier, it abstracts all of or conceals would be a better word, all of the technical aspects of connecting to an API. So the analysts would not need to worry about proxies, about what kind of GET requests are being made, about parameters passed in the URLs. None of that would actually, or the return format for that matter, none of that would actually be relevant at all to the user. And I kind of use this in jest, but Drill, quote unquote, speaks database. So if you wanted to use a BI tool such as Tableau or Clicks or something like that, you can just connect that directly, and now all of a sudden all of your API data is queryable quickly and easily. And so what you have to do in order to make this work is you obviously have to have Drill running, but you have to first define the API connection information. And this would be available in any API's documentation. So this would be like the URL and any kind of credentials that you might have to set up. You also have to tell it explicitly what is the format of the returned data. So in other words, you have to tell Drill to what to expect when the query is done. Now, again, this information would be available in the documentation for whatever API you're using. And this is really as simple as filling out a form, and that's a one-time cost. Once it's done and configured, you don't have to do that again. Now, Drill currently for the APIs will support JSON and CSV. XML is kind of on the roadmap. Now, so that's what you have to do to get it to work. One of the things that you don't have to do is tell it what kind of schema to expect in advance. And that's a big deal also, because when you execute these queries, you don't want to have to do a lot of prep work. You want to just query it and go. So there's no need to define a schema. Drill can infer the schema of the data directly from the query results. And so this is what it looks like. This is Drill as connected to a open source BI tool. And you can see at the top there's an SQL query. And then at the bottom, these are the results that, that came back from this query. This is querying an API, which I'll show you at the end of the presentation. Now, there's also a notebook interface. So you can, if you're more comfortable doing, working in a Jupyter notebook, you can see here, there's just kind of some standard, some import stuff, then you execute this drill connect statement. And then once you've done that, then you can just type in an SQL query and it will get populated into a data frame, into a pandas data frame for you. And if you wanted to do further machine learning on that data or whatever, it's very easy to do that. And I would just also like to point out the syntax of this query. So if you're familiar with SQL, this should look very, very simple for you to understand. This is selecting every field from this API, which is called stock. And then we're setting a filter on where symbols equal AAPL. So let's walk you through a simple API. So the first example we're going to use is this web page called Market Stack, which is a stock price API. If you wanted to try this, this is an easy one because this can be accomplished with GET request. So you can cut and paste this directly into a web browser and you'll get these results down there at the bottom. So what you see here is the URL for that is in there. The only thing you have to do is you do have to register for an account and provide an API key. So you can't just cut and paste this, you have to register and then you get an API key. But once you do that, then you get the data that is right down there at the bottom. And so once you've made that connection, a query might look something like what you saw earlier, select star from API.stock where symbol equals whatever. And that would get you a nice clean table as you see there at the bottom. Now, because Drill uses full ANSI SQL, you have the full power of SQL available to you. So if you want to remove columns, filter columns, perform calculations or functions on columns, it's very easy to do that as well. So if you notice here, we're taking the date and then the difference of the closing and opening price and calling that delta, and then we can execute that query and you can see the result there. So if we had this data, we could then plot it very simply, and it becomes very easy to do this kind of work once you're able to access this data in this manner. So let's take a look at something that's a little bit more complicated, and that is Jira. Now, I would assume that everybody listening to this talk is familiar with Jira, but if you're not, Jira is one of the more popular project management, agile software, the agile boards or Kanban board software that's out there, and it's commonly used in the tech world. Now, Jira does have an API that you can access your project's information. What I've found is that while Jira is a great tool, oftentimes it can be difficult to extract certain types of reports from Jira that upper management might want, especially management that's not familiar with agile methodologies. So this is kind of why I was interested in doing this. Now, this is significant. There's a lot more complications here. First off, it uses OAuth authentication, meaning you have to pass it a username and a password. The API also uses post requests rather than GET requests. You can't just paste this into a web browser. And the data that is returned is extremely complicated, nested, ugly, gross data. So we have a lot more work. We can't just query this and dump it into an Excel spreadsheet. However, all of that can be hidden from the user. And so this is what the Jira API returns. If you just do a kind of a simple query, you can see this is what you get. And it's pretty ugly. Yeah, that was my reaction. Now, by executing this query, we can clean it up considerably. Now, I'm going to just kind of talk through this. There's a subquery in there. What that's doing is that's taking that raw, ugly, nested data and flattening it. So it's breaking it at all the records out into individual rows. Then from there, we're selecting key fields that we want from this, and you can see how many nesting levels there are, and just renaming them so that they are named, easily. And then the last step is converting the timestamps into actual date time objects. Now, while Drill does a decent job of inferring the schemas, it doesn't always do a great job of inferring data types. So we have to do a little work to do that. So once you've done this, though, now we have this beautiful table instead of the mess that you saw earlier. Now, what you're seeing here, there are two things that are blocked out because this is like real data, but what you're seeing here is now this becomes very easy to do further work with. Now we can even make this better. What we can do is we can create a view which completely will hide all of that other stuff that you saw, and then you can just execute a query like select star from this view, and then you don't have to even think about all that other stuff. So once you've kind of done your data exploration and cleanup, you can preserve that and then query this just like that. And that also will get you the correct data types because we saved that last time. And we can create interactive dashboards from this. So the chart on the left shows you how many issues were created over time, and then how many issues by type. So we can do some data exploration. Now, the final demonstration, which I wanted to walk you through, is a COVID-19 dashboard. This is a dashboard that's available at covidtracking.com. I'm going to say right now that the quality varies greatly in this API. It gets better as time progresses, but it's reporting from from all the states in the US. So some states have much better data reporting than others. So it is what it is. This one is relatively clean, so there's no complications in terms of authentication or any of that kind of stuff. The results are returned in JSON format, so that's good. But what we're going to do here for an kind of more interesting demonstration is that we're going to take this data that we're pulling from the API and we're going to join it with some static CSV data that's on my local machine. And so in order to do this is the configuration that we need to set up for Drill. And you can see really the only thing there that we actually have to do is specify the URL and that it's going to receive JSON, and that's really the rest. That's really all we have to do. And so once we've done that, we can do a select star from what you see here, and that gets you a basic query, which the results are here. Now, this particular API has a number of different data sets that are available to you, and that's why it has this states/daily.json. So you can get other data sets from this and you can put different arguments in that last bit in the query. Okay. So to demonstrate how to join this API data with something else, all you have to do is use a simple SQL join. So in this case, we have this population spreadsheet, and that looks like this. And to join this is the query to do that. So the only difference there is the last line where we say join dfs.test, and then that gets you this table. So now what we can do is we can calculate per capita numbers instead of just the raw counts and so forth from the COVID data. And to demonstrate this really quickly, I'm going to just pull this over here, and so that query that you saw is being used to power this dashboard that you're seeing here. And so these are the trends from this. And so if we want to filter this, we can provide interactive filters. So let's see how Maryland's doing. And so this is data that is being pulled live from the API, merged with the JSON data that you saw. And this dashboard took me about 15 minutes to actually build. And so, and again, no ETL, none of that. And my goal here in doing this is, I believe that, and from my observations, is just that doing this kind of analysis, the tools make it much harder than it needs to be. And so my goal is to decrease the amount of overhead and rapidly decrease the time that it takes for an analyst or a data scientist to go from raw data to producing something of value. So if this is interesting for you, I'm happy to chat with you more. I want to thank the organizers of the conference for inviting me, and thank you all very much.
Thank you so much, Charles. We really appreciate you sharing all of your knowledge with us. All right, if you'd like to drop questions in the chat, feel free to engage with him this way. Also, if you're looking for your next session, you can go ahead and check out the program page or take some time to connect with your peers with some virtual networking. Thanks again, and we'll look forward to seeing you around.